Hello friends, welcome to the online course. Now in this video we are going to see one of the novel and innovative way of the machine learning algorithms, and this is a semi-supervised learning. Semi-supervised learning is just like not completely supervised or not completely unsupervised learning also. So what exactly is it? It's a combination of supervised learning and the unsupervised learning. Let's focus on the theoretical concepts behind it, and then we are going to see how exactly we are going to make use of the semi-supervised learning algorithm with Python. Let's start with an example. Let's say we have a simple image classification problem. So our training consists of two labels images as shown. Like the first image is an eclipse, this one, and second image is a non-eclipse image. So in our classification system we are going to find whether the image belongs to eclipse or not eclipse. So we need to classify images of eclipse from a non-eclipse images, but the problem is that we need to build our model on just training set of two images, just two images. So what do you think? With the help of these two images, is it possible for a classifier to find the features and classify which are eclipse and which are non-eclipse? So we need to classify images of eclipse from the non-eclipse images, but the problem is that we need to build our model on just training set of two images. Therefore, in order to apply any supervised learning algorithm, we need more data to build a robust model. Okay, we have seen this already. When the data size is more, your feature extraction will become more and more powerful. Classifier, the model, machine learning model that we apply, that we use, will be more effective only when a huge amount of the data is available, so that the extracted features will become more effective to classify this particular data. So to solve this problem, okay, so we find a simple solution that we download some images from the web to increase our training data. Okay, so we need to increase our training data just like this. So it's a combination of eclipse images and the non-eclipse images. Okay, so what exactly, the labels are not given there, so we need to assign the labels manually. Okay, so supervised approach, we also need labels for these images. So we have downloaded it, but we don't know whether these images are eclipse or non-eclipse, so we have to manually classify each image into a category as shown here. Check it out. So which are the eclipse images, which are the non-eclipse images that we have classified, and one by one we have to assign the labels to these particular images. So we are doing this operation manually. The problem is that we are having a training data partially classified, partially non-classified. So based on the classified data, remaining data we need to classify. That's our main aim of this particular method here. So after running a supervised algorithm on this data, our model will definitely outperform the model just containing two images in the training data. Okay, but this approach is only valid for small purposes, because human annotation to large data set can be very hard and expensive. So to solve this type of problems, we define a different type of learning known as semi-supervised learning, which is used for both labeled data, just like supervised learning, and unlabeled data. I'll just revise what we have done in supervised learning. In supervised learning, we were having the input and output. So outputs are the classes, inputs are the features. So we are going to find a relationship between the input and output, and then we are going to do the predictions on supervised learning. In unsupervised learning, just like clustering, we are not having the labels. So we created the groups based on the similarity notion within the data, and then the output, the labels are generated and then they are assigned. That's what we call as the unsupervised learning. Now we are going to make the combinations of both. That's what we call as the semi-supervised learning. Now say this one, what we have done already, supervised learning, all labeled data, input output both are there, and then our model is created. Okay, in unsupervised learning, we are all unlabeled data. Based on the similarity notion within this data, we are going to create the groups and then we assign the labels to them. That's model is built. This is what we call as unsupervised learning. And the semi-supervised is a combination of both. So some labeled data is present and lots of unlabeled data are there. So what we are going to do, labeled data will be used, and based on the labeled data we are going to assign the labels to unlabeled data, and then the model is formed. This is what we call as semi-supervised learning. So semi-supervised learning is a combination of supervised learning and unsupervised learning. Take from supervised learning and used in unsupervised learning. That's what we are going to make use in the semi-supervised kind of machine learning modeling. Now, this concept we generally term as a pseudo labeling. We assign the labels. So just check it out. So first, for example, I'm having label data something like this. Two classes are present inside it. Okay, so one is orange, another is blue, and this is unlabeled data. This does not contain any kind of classes inside it. So what we are going to do? Train the model with the label data. Train the model with the label data. Then use the trained model to predict the labels for the unlabeled data. So first create the model. That's like supervised learning we use. Create this particular object by this data, okay, and then predict the output for this particular data. Predict the labels for this particular data, and then we get the output. So we'll get the labels for this data also. Like this data will be converted into this format. This is unlabeled. Now the classes are assigned. Orange and blue classes are assigned. Fine. And the third case, retrain the model with the pseudo and label data sets together. So combine them together and a perfect data set is formed with us. And then after that, we are going to build a new model of machine learning. That is what supervised machine learning there. And then we are going to do the prediction of new classes based on this particular data. This concept we generally termed as pseudo labeling, and this pseudo labeling is performed by the semi-supervised learning. So what's that? Semi-supervised learning can be positioned halfway between supervised and unsupervised learning models. Semi-supervised learning problem starts with a series of labeled data points as well as some data point for which labels are not known. The goal of semi-supervised model is to classify some of the unlabeled data using the labeled information set. In short, here we are going to find the missing output. We have already seen the missing input. How to predict the missing input? So we can predict the missing output also. So missing outputs are predicted with the help of the semi-supervised learning. Now why? What's the goal? What's the purpose of using this kind of the learning mechanism? The goal of semi-supervised learning model is to see same as supervised one, to predict a target value for a specific input data set. Alternatively, other segments of AI community see semi-supervised learning as a form of unsupervised learning with constraints. This is what we call unsupervised learning with constraints, and this is semi-supervised learning is. Now, few of the applications, some of 3 applications I am showing over here for semi-supervised learning. First is speech analysis. So it's a classic example of value of semi-supervised learning models. Labeling audio files typically is very intensive task for require lots of human resources. So applying SSL technique can be really help to improve the traditional speech analytic models. We can assign that. We can assign the labels to unlabeled speeches, and based on that analysis are possible. Protein sequence classification. Inferring a function of proteins typically requires active human intervention. So this will be done. This can be done automatically if you're already having a classes. Okay, so we can predict the unclassed proteins also. Web content classifications, very interesting algorithm which will work on the webs, organizing the knowledge available in billions of web pages will advance different segments of AI. Unfortunately, that task typically requires human intervention to classify the content. What sort of contents are available in a particular web page that we can classify with the help of the semi-supervised learning. So get the labels from the originally available data set, data or the news or the information on the web page, and predict new labels for the new data present on the web page. So this is web content classification. This can also be done with the help of the semi-supervised learning. There are few essential characteristics that should be present on a problem to be effectively solvable using SSL. So 3 different essential characteristics are there. The first one is sizable unlabeled data set. Now remember, in the SSL scenarios, the size of unlabeled data set should be substantially bigger than the labeled data. Otherwise, the problem can be simply addressed using supervised algorithm also. Input-output proximity symmetry. SSL operates by inferring classification for unlabeled data based on proximity with the labeled data points. Inverting that reasoning, SSL scenarios entail that if 2 data points are the part of the same cluster, just like k-means, their outputs are likely to be close proximity as well. Complementary, if two data points are separated by a low density area, their output should not be close. And the last one, relatively simple labeling and low dimension nature of the problem should be present. So in SSL scenario, it's important that the inference of the label data doesn't become a problem or more complicated than the original problem. So this is in AI is known as Wapnick principle, which is essentially state that in order to solve a problem, we should not pick an intermediate problem of a higher order of complexity. That's what the prime and the common requirements of the SSL are. Now, let's come to the original point here. What are the algorithms? Which kind of algorithms are available in semi-supervised learning? So, there are commonly used two algorithms are present: label propagation and the label spreading. These two algorithms are used to perform the semi-supervised kind of the tasks. So, let's understand how exactly this algorithm works first, and then we are going to see these algorithms practically in our applications. Let's go. Let's start with the first, label propagations. So, label propagation algorithm is an iterative algorithm where we assign the labels to unlabeled points by propagating labels through the data set. This algorithm was first proposed by Xiaolin Zhu and Jobin Gharamani in the year 2002. LPA comes under semi-supervised learning as we want to predict labels of unlabeled data points which are already given to us. Now, let's go conceptually how exactly LPA label propagation algorithm perform the operations. Now, let's see. Assume that we have a network of people as given below with two classes, interested in cricket and not interested in cricket. So the question is, can we predict whether the remaining people are interested in cricket or not? Say this one. So a lot of people are present, so they are having some features. Based on that features, they are just plotted on this particular 2D plot, and you just can see identify someone. So these people which are shown in the red circle, they are not interested in cricket, and the people which are shown in the green circle, they are interested in the cricket. Okay, so two classes are there, interested in cricket and not interested in cricket. Now, what about the remaining one? So apart from this particular 8 to 9 people, 10 people, sorry, remaining people, huge crowd is present there, almost more 50 people are present for which are remain for classification. Now I want to find which of these people will be interested in cricket and will not be interested in the cricket. That's what my task is. So 10 samples are labeled and almost 50 samples are unlabeled. So based on these 10 samples, okay, we are going to make supervised learning, and we are going to create the labels for the remaining 50 samples applying unsupervised learning. So creating it a semi-supervised approach here. Now, how LP algorithm will work to perform this operation, that we are going to see now. Now, for LPA to work in this case, we have to make an assumption. An edge connecting two nodes carry a notion of similarity. That is, if two people are connected together, that means that it is highly likely that these two people share the same interest. Okay, just like we are using K-means clustering, the people who are near, who are connected together, who are nearest, so they can be converted into the same label, into the same class. We can make this assumption as people tend to connect with people having similar interest. Correct, that's fine. So if similar interests are there, then only people will get connected to each other, and this principle is used here to create the algorithm of the label propagation. See, so let's walk through randomly through the graphs. So just take an example given in the figure where we have two labels, classes red and green, and we want to predict the label for 4. Check it out. So for example, one snapshot of this graph is connected here. The numbers are shown 16 and 14. These two people are belonging to green class, that they are interested in the cricket, and 1 and 8, these two people are there in the class red. It means that they are not interested in the cricket. Okay, and remaining other are unclassified. Now I want to classify number 4. So I just want to find 4 will go in the 16, or it will go in the in green, or it will be in red. Okay, green and red. I am not going to find any distance of it, but my task here in this algorithm of LPA is to find multiple paths by which this particular point will reach towards the final class. It means that I want to find a path of 4 to 16 or 4 to 14 and 4 to 1 and 4 to 8. Means how many possible paths are there. Where maximum number of possible paths are present, that class it will be going through. Okay, so final class will be decided by the highest number of paths available. So let's see how many paths are present. So if you go from 4 to 16, so 4, 9, 15, 16. Okay, 4, 9, 15, 16, 4, 9, 13, 15, 16. These two paths are there from 4. If you want to go towards 14, so 4, 9, 13, 14, then 4, 9, 15, 13, 14. Okay, so these two paths means from 16 two paths are there, 14 two paths are present. Okay, no more possibilities are there. Okay, so overlapping must not happen. Now from 4 to 8, let's see, 4, 7, 8, then 4, 5, 6, 7, 8. Okay, done. Okay, so two paths are there towards 8 also. Now 4 to 1, so 4, 2, 1, 4, 5, 1, 4, 7, 6, 5, 1. So three possibilities are there towards 1. Now let's look at it. In green, 4 possibilities are there, and in red, 5 possibilities are there. So 2 and 3. So from 4 to 8, we have 2 possibilities of paths. 4 to 1, 3 possibilities of path. 4 to 16, 2 possibilities of path, and 4 to 14, 2 possibilities of path. So here 4 are present and here 5 are present. So which one is max? 5. It means that 4 will go into the red class. Check it out. So these the paths which I have given, walking paths from 4 to 16, 4 to 15, 14, and in red 5 are possible there. Means if you want to go to 1, so 3 paths are there. Okay, so based on all the possible random walks starting from node 4, we can see that the majority of the walks end in the red node. So we can color the 4 into red. So this is how your propagation algorithm works. Okay, so this is a common and simple example, simple formula or simple methodology which is applied by LPA to classify or to label the unlabeled examples in the data set. Okay, so there are some problem that LPA will be having. We are going to see this LPA with practical implementation of it. LPA uses the labels of already unlabeled nodes as the base and tries to predict the labels of the unlabeled nodes. However, if the initial labeling is wrong, this can affect the label propagation process and erroneous labels may get propagated. So to overcome this issue, label spreading is introduced. Okay, so remember that if already labeled nodes are base, try to predict the labels for unlabeled nodes also. That's the problem over there. So label spreading is used where we learn the labels of labeled nodes as well as while learning the labels of unlabeled nodes also. So sort of applies some label correction as well. So to overcome this problem of LPA, LS, that is label spreading algorithm, is introduced. Now let's see how label spreading actually works. The label spreading algorithm works by representing a document as a point in space and then finding all the other points which are closest to it than say another document somewhere else present. This algorithm can then work out how the rest of the labels blog post should be labeled based on how close or how distance they are from the training group. It is also possible to give algorithm a degree of freedom, it's called as clamping, so that it can relax the boundaries and reassign some unlabeled data to the adjacent category that is more appropriate. So here grouping is worked. In case of label propagation, there is one-to-one interaction is used. That's the main difference that both of these carries. And if you go mathematically, what's the difference that label propagation and label spreading is having? It's just like key idea of these two methods essentially same, but the difference lies in terms of the transition matrix used for actual implementation. Label propagation uses the graph Laplacian while label spreading uses the normalized graph Laplacian. Okay, so these two, that's the main difference, that transition matrix that they are using over here, and based on that the operations are performed for giving the labels to unlabeled samples. Okay, so that's what we are going to have the basics behind the semi-supervised learning and the algorithm that we use here in this system, that is label propagation and label spreading. And now let's go to check the classes of the missing values. So to understand this algorithm clear, we are going to use the commonly used data set called as iris. Okay, we have came across this algorithm already, like these are the properties of the iris flower. Okay, so this sepal length, sepal width, petal length, petal width, and the final one is the class. Okay, so we just can check it out. The class which I have shown over here, they are okay. So I'll just go to my data sets here. Okay, let's check the data set and how exactly the predictions are possible, that we'll focus on. I'll just open my CSV file which is shown on the presentation also, and then I'm going to use this file to predict the labels for the remaining data which is not given the labels to it. Okay, so this is my iris.csv file which I'm using in here in semi-supervised learning. Check it out. Many are labeled, but if you are not labeled here, you can check it. 30 number, this is 36, 38, they are not labeled, they are not having any label present over there. Okay, check this. Here also 2 are missing, so this is also missing, this also missing. Okay, so these labels are not present and available. Few are, I think 3 are from setosa, 1 is from versicolor, and 2, 3, 4 are from virginica. They are not assigned with the labels. But I'll make one more delete here. Okay, yes, so let's close this, and now we are going to see this by practical implementation of it. 3 packages I'm importing: pandas, seaborn, and the numpy. So let's start coding this. Okay, so packages will be imported. Now let's read the CSV file which we are using over there. This is by using pd.read_csv, iris.csv, which just I have shown will be reading it. Okay, so let's check it out. So before actually starting, I'll just check out the shape of this. See, 150 rows and 5 columns are present inside it. We know that spaces is the output column. Okay, so 3 spaces are present inside it, and how many entries are present within it, that also I'll show you. See, this is setosa, versicolor, and virginica. In actual data set, all are 50, 50, 50. But see, some missing values are present. That's why they are not reached towards 50. Okay, so by using SNS count plot, I'm showing the plot for this particular spaces. Okay, now let's see. In the whole data frame, let's see how many values are actually missing. So by using is null, means something is nan values present there, nan, that is not a number, and their addition I'm making over here. So you just can check it out. Sepal length is 0, sepal width is 0, petal length 0, petal width 0. These are non-missing values. Nothing is missing in this data, input data. But if you focus on the last column, that is species, so 9 values are missing there. It means that 9 values are having nan present within it. Nan present are there, not a number are present over there. That's why they are shown as missing values. And if you are going to print it, then also it will show the nan. I'll show you that one here. Now let's separate your input and output. X is equal to df.drop species. So this is output variable which I am dropping from there as a column. This column will be dropped, and remaining 4 I'll be keeping into the variable X. Okay, and output variable species I am keeping in Y. So X and Y are now separated. Okay, so I'll just print this Y here. Check this. Okay, so this is Y. Check it out. This with missing value shown as nan, not a number. So we already seen this in missing value concept. Say this, these are the missing values. Okay, fine. And if you want to show, So is null dot sum. Okay, 9. So total 9 missing values, 9 nan are present there. Now before actually working in algorithm of LPA or LS, it's compulsory that the class which is not labeled, it should be denoted as -1. The class which is not labeled should be denoted as -1. So what I require, I want to, or I have to replace all the nan values by -1, all the nan values by -1. So what I have done over here, I'll be using the replace method of the series class. So two parameters are there, wherever I am getting nan. So remember, nan is a constant which is which we can represent from the numpy. It's a numpy constant. So np dot nan. So wherever I am getting nan, replace that nan with -1 string. Okay, wherever I am getting a nan, replace it by -1. That's what I am doing over here. So I just replace all, and now let's see what exactly we are getting here. So all these values are replaced. See, now all the nans are replaced by negative values, -1. So it's not represented as nan. Now this missing class, -1 means the class is missing, label is not given there. So total unlabeled samples are present, that's why these values are not present. Now it has become 0. Okay, so if you go to check the y, instead of nan, I'll be having negative value -1. See this one, okay, negative values are present there. Fine. So my data set is now prepared. Missing values I have converted into the -1 format. So they are presented as a negative values, means their class are not labeled. That's a pre-requirement of the label propagation and the label spreading algorithms there. Now let's see. So in our package sklearn.semi-supervised, from sklearn.semi-supervised, we have to import the label propagation algorithm. So label propagation is a class by which you have to create the object of it, and after that we are going to do the predictions for the unlabeled samples. So from sklearn.semi-supervised, import label propagation. Okay, so it's imported. Now there are some few parameter I'll be using over here in label propagation. SSL is equal to, okay, so SSL is the object, semi-supervised learning. Label propagation, kernel I'll be using RBF. So here label propagation also contain kernels. So I'll be using the kernel RBF, radial basis function kernel, just like we have used in SVM algorithm also. Gamma value which RBF kernel requires, I'll be keeping 10.0. Okay, randomly I'm just kept that one. And then the object of the label propagation is created. So let's run this. Okay, and remaining tasks are same which we are used for other supervised learning algorithms. So I just created the object of the label propagation object class here, SSL, then SSL dot fit x comma y. So let's train the algorithm with the given data. So train it. Yes, the algorithm is trained. If you want to see the output, this output was suppressed. Check this one. Okay, so we have trained the algorithm with the given data. Okay, and now do the prediction. So how exactly I have done that? See, I have not separated my data. I have not done train test split because I don't require. The train test split is required only for the supervised learning algorithms. So here we have semi-supervised, here we are having predict. Okay, so what I've done, SSL object is created, is trained, and now I'm going to do the predict. Now this predict will work on the missing values where it's given negative. So algorithm will whatever concept which I learned in theory, this will be applied here, and based on that the samples which are unlabeled, which are given -1, will be predicted with a new sample. So SSL dot predict x, and let's see the predicted values. Okay, so it will return the variable name is predicted, and inside this predicted we are going to have all the samples, all the labels, all the output which are labeled there. So let's see what exactly we are getting there. Check it out. You can see almost all are labeled here. Yeah, there is no negative value present over there. Wherever you are getting -1, there the label is assigned. Okay, except -1, 3 labels were present inside it: Setosa, versicolor, and virginica. You can check it out. All are removed. Maybe some errors are there, maybe. See, all they are clean almost. Okay, almost they are clean. Only, okay, here I am getting -1. The remaining others are not, almost all are clean. So only one -1 which is not predicted. Maybe so accuracy of this algorithm is not 100%. Okay, on this data, check it out. All they are cleaned output variables. And now let's see the accuracy score of it. So this is how we are going to do the predictions. So my output variable is cleaned with all the entries which I have predicted. 9 entries were missing. Out of it, I think only one is unpredicted and remaining others are predicted correctly. Now let's check for the score. Score is accuracy score. How this algorithm will work on my given data set. Okay, how it is effectively working on my data set, that will be identified by the function score. Okay, so let's go for object SSL dot score. So this is the input and this is the output. I'm going to use this multiply it by 100 and check the accuracy score of it. Accuracy is 94.0%. okay, it's fine. It's 94% almost accurately classifying the unlabeled data. Okay, so that's how we can find the accuracy of the algorithm for the given data. Now what I'm going to do, I want to identify now some analysis which we have already done, and based on that we are going to find we are going to attach this predicted samples to the original data. So I will count now. We have already seen how many missing values are present, 9. Okay, now nan is not there, we are having -1 and non-missing value. So to do this one, what I am going to do, so I will convert this into the countable format. So what I have done by using np.unique, okay, whatever predicted classes are there, so these predicted classes I am converting and total unique values and their counts, they are returned by using it. Unique values, so 4 unique values are present inside it, that is Setosa, versicolor, virginica and -1. Okay, and their counts, they are returned by this. Okay, return counts 2, it will show this one. And after this we have seen np.unique only, so unique will return only unique values, but I want the counts also. So both of this I am just returning from there, and then I am creating a dictionary by zipping them together. See this one, dictionary by zipping them together. So zipping is done. You can check it out now. -1, -1 is present 1 number of times, Setosa 50 number of times, versicolor 49 number of times, and virginica 50 number of times. So out of 9, 8 samples are labeled. Only 1 is missing because it was 94%. So 1 was missing, which is shown over here. Remaining others are, means 8. For 8th time it has successfully given a label, but for 1 time it is not possible to give the label there. That's why it's showing 1 which is missing. Fine. And let's go for predicted objects. Check it out. So almost all have reached towards 50. Only versicolor is missing 1. Okay, maybe you can identify that this negative is also versicolor. This is our assumption. We know that already, but maybe on some complex data set it's very difficult to find the unlabeled samples which are not given by the algorithms. Okay, so 8 are cleaned, only 1 is remaining now. What we can do is we can delete that row also if you are not sure about the class of it. So see this one, all become 50 almost, only 1 is -1. And now the labeled samples I am going to apply to the original data set. So in df we have this output as species, output variable, and predicted is the output which is generated by the algorithm, by the semi-supervised learning algorithm of LPA, which you have generated. And this predicted data, predicted classes, I'll be applying to the column of species. Okay, so let's say this, it's applied, correct. And now I am going to delete the entry which is containing negative value to it. So how to do this one? So what I have done, df.drop. I don't know at what position number it is present. I want to find the position of it. So position, how to find that one? df of df.species equal to -1. So wherever species column contains -1, okay, find the index of it, location number of it, row number of it. That row number will be returned by this particular statement, and that row number will go to drop function, drop method of df, and that particular entry which contains spaces equal to -1 will be deleted by this. So that entry is deleted, and now let's see the shape of it. Yes, out of 150, 149 entries are having correct classes, 5 columns, and my data is now cleaned. Classes are assigned to the unlabeled samples are assigned with the labels to it. My data is clean. My data is now perfectly available for me to use for any supervised learning algorithm or any clustering algorithm also. And let's see some. Okay, sepal length 0, sepal width 0, petal length 0, petal width 0, species are also 0. Okay, that's it. That's how we are going to clean the output variables. That's how we are going to make use of the labeled data to label the unlabeled data with the help of the label propagation algorithm. So this is how label propagation algorithm work. Maybe its accuracy is not 100%, but in some cases, in many cases, it may achieve the accuracy towards the 100% also. Now, the inverse to that, we are having label spreading algorithm. It's not different or some difficult to implement. Similar kind of data set I'll be using. I'll just changing the class only, and let's see how exactly it's differentiated. So I'll just go step by step in the same direction, not much explanation, but only changing the class of it. So let's import the packages. Okay, read the data, see the count plot. Okay, so how many entries? 9 are missing. Separate the input output, replace nan with -1, and now this is important. In semi-supervised, we are having the label spreading class. Okay, so second class where the training group is used to compare with the unlabeled sample. Okay, so from sklearn.semi-supervised, I'm importing the label spreading class. So import it. Let's create the object of it. Okay, label spreading with similar kind of operation, only alpha value I'm set to 0.2. Okay, now SSL object I have created for label spreading. Now train it, predict for the samples. Let's see the predicted for this case. I'm just changing the algorithm label spreading, and now let's see, is there any missing? Okay, single same missing value is present here also in label spreading. Single missing is there. Okay, fine. All are out of 9, 8 are now labeled and 1 is unlabeled. Let's see the accuracy of it. Same accuracy I'm achieving here. Then return the unique values and their count. Okay, same count plot I can see. Okay, then put this predicted value algorithm in the output variable. Then delete the column which is containing spaces equal to -1, which is already not classified. Okay, check the shape and see finally all are 0. So this is how exactly the semi-supervised learning algorithm works. It's a combination of supervised learning and the unsupervised learning algorithms, and based on this particular algorithm, we are going to predict the labels for the unlabeled samples. So 50% we are doing supervised learning, and the remaining 50% we are doing the unsupervised learning kind of system. So whenever we are going to have this kind of requirement, this kind of things in our data set, we are going to make use of the semi-supervised learning algorithms. So this will work as per the requirement of the data sets when it's expected, required in the program or project, so we can make use of this algorithm effectively in your system. Okay, so the methods of communications are available with you on your front screen. You are free to ask the queries if they are not working. Program is also given to you. Thank you. Thanks a lot.